Okay, good evening, everyone. So this is basically, as you know, it's a Spring Boot session. In this course, you will largely be learning how to develop an application, a web application, basically using Spring Boot. You'll learn about client server architecture and lots of things. Many of you here are repeating students, like who took the session before as well and now are coming again, and many of you here are new. This course has been designed in such a way where okay, before I get into that, so the tutorial here will be mostly done in English because that's the instruction. But if anyone here is more comfortable in Hindi and have doubts, you guys can throw me questions in Hindi and I'll be more than happy to help you. Okay, so there's no language barrier here. Uh, that's it. So yeah, so the way this course has been designed is that in the last iteration, when we ran this thing, we figured out that there were many core Java concepts which were missing. So we have decided to include those. So how it will happen is we will start with the only those Java topics which are going to be required in Spring Boot. Okay, we're not going to go in depth, just those ones, and then we'll work on we'll start with the Spring web application. Then after the Spring web application has been done, we will move into the database fundamentals. Once that is complete, we'll see how Spring does the database part. Okay, so everywhere we enter a new concept, we'll understand the fundamentals first, and then we'll see how Spring does that. Okay, this is how it will be. And if you have any questions, we'll take a break of 10 minutes every hour. So just stop me and ask me questions if you have any. All right. Okay, so today's topic will be basically exception handling. Uh, Many of you probably don't know how to what that is or how that is done. Many of you do know. Those who know, please bear with me. Okay, let me share my screen. One of you can confirm if you can see my screen. Anyone?
Yes, sir.
Okay. And if you have any issues with the noise or background noise, immediately let me know. Okay. Cool. All right. So what are we learning today? We are going to learn these things: exceptions, uh, checked versus unchecked, which are also known as compile time versus runtime. Okay. We'll learn how you can define your own exceptions. Okay. All right. Let me just open up the chat window here just in case somebody has any questions. Okay. User defined exceptions. Then we'll basically see the difference between throw versus throws. Okay. We'll see what finally does. Actually, we'll see try catch. Okay. Uh, Multi catch. Okay. These are nothing too difficult. But so this course assumes that you have basic understanding of Java. Okay. Uh, yeah. So for this, and I'm going to use basically Linux machine. But that really shouldn't be a problem for you guys, because even if you are on Windows or Mac or anything, the commands that I'll type here are similar to what I'll be. I mean, if you are on Windows or Mac, the commands will be same. Okay. And for IDE, I'm using IntelliJ Community Edition. If you have Eclipse, you can also use that. Okay, but I'll be following IntelliJ throughout the course. All right, so make sure, and I believe you should have Java 1.8 installed here. Okay, so just to verify, we can type this command Java version, and it will show you that 1.8.0 is installed. Okay, if you have a version higher than this there is no problem. Make sure this is the minimum version that you have. Okay, cool. Right. A couple of things that I have to do is I'm going to create a folder basically. Okay, and this is a March 22 batch, right? So let me go ahead and create this. You can ignore these commands because it's just for this purpose. This is where we'll be keeping our code base. So in here, I'll link this to a GitHub repository so that anytime you need to look back at what I have done, you can check the recording, and at the same time you can check the code base here. Okay. I don't think we have linked the Git repository yet, but after this tutorial, we'll do that. Okay. So what we'll do is we'll first create a project here. I'll say new project. If you're on IntelliJ, okay, here you can see that the first thing is, if you're on IntelliJ, it will ask you something like this. Okay, this is what they'll ask you, what type of JDK you want. So in my machine I have both 17 and 11, but I'm going to use 8. So I'll say add JDK, and it will basically ask me where my Java 1.8 is installed. In my case, it is installed in apps and JDK 1.0. This is where my JDK is installed. Okay, so I'll select that, and you can see that it picked up this thing. Okay, any doubt so far? This is like very basic things. Okay, so I have selected my project SDK here, and I'll go next. Okay, we'll change the workspace here. Okay, again, for me the workspace here would be March 22 BE. Okay, there is no, so I'm going to create a folder inside of this, and I'll call it exceptions. Okay, this will be my working directory for now. So yeah, project name will be exception. I cannot give the project name as exception, so maybe like basics of exception, something like this. Okay, let's finish this. This will take some time to set up the events and everything. While this happens here, let us understand what exceptions are in general. Okay, so I'll be using something called web whiteboard. Okay, basically a free online whiteboard where I can, explain things much better. Okay, all right. So imagine a scenario. Okay, imagine that you are given a task. Somebody has given you basically personal information like name, age, and email address. Okay, let's actually write down the cases here. Okay, uh, you have something like let's say, I don't know, John. Okay, this is the name, and then somebody has given you something like 29, and let's say, okay, okay, so let's say you have to write a Java program which is going to validate all these three things. So what are the conditions here? Condition is that name should not be blank. Age should be greater than 18 and less than 60. Okay, just imagine a scenario, okay, that you have to validate this thing. Okay, email should not be blank. Okay, okay, so let's say we have to do these things. So in a typical scenario, what happens is, if I draw a flow chart here, okay, it looks something like this. You give your input here, okay, validate name. Okay. Let me know if you have any issues with anything. Sorry. Valid. So I'm just stepping out the, like, I'm just writing out the steps that are required to do this thing. In any scenario, if you are given an example, if you're given a condition that you have to validate these things, this is how the steps happen. Somebody will first give you the input, okay? Then you will have to validate the name. Then you will have to basically validate the age, okay? And then you will have to validate the email, okay? And after that, you will basically have to return, okay? If I give you a task of validating anything through your Java program, or let's say I say that write a Java method which takes an input and validate these three things, you will be doing these things. But let's say I give you a condition that if any of the validations fail, you will not allow it to proceed to the next step, which means that if the name phase fails, they're not going to go into these steps. If age validation fails, they're not going to move on to the next step, okay? Java or JVM gives you a way to basically disrupt the flow. If all your input was incorrect, it would first go from this step to this step, then to this step, then to this step, and then to this step, okay? But if at any point you have an issue where you do not want to continue further, you have to immediately stop the execution. Give me 1 second. Yeah, sorry about that. Yeah, okay. So basically, this is where exceptions come in. The purpose for having exceptions is to stop the execution at a certain point, okay? So let's say if you have a failure in the validation of age here, okay, you would probably just throw an exception here, right at this point, okay? Let's say age not valid, some kind of exception here. And then what will happen is that the flow will basically return from this point onwards, okay? It won't even continue to this point, okay? This is basically what why we have exceptions. So before I go into classifying what types of exceptions are there, you need to know what exactly is the purpose of having an exception. You want to stop the execution at some point, you throw an exception, okay? You introduce an exception, system will stop right there, okay? Okay, so let's understand one more thing. You guys know the method calls things, right? Let me introduce you to something else called method call stack, okay? What is this? Let's write a simple Java code here, basically to understand what to explain what I'm trying to mean here. So let's say you have a sample A class, okay? You have something like this, all right? And similarly, you have something called sample B. So I have just created two classes here, okay? This here has a method void do nothing, okay? All right. And this here has, let's say, it has this main method here, okay? Okay. In order for me to call this method here, okay, first thing I have to do is I have to create an object of that. So I'll say sample B, okay. And then basically I'll be able to call this do nothing method, okay? Now imagine there was another class called sample C, okay? This had a method called void do something, okay? Right? And let's say that sample B wanted to basically call that method, Okay, so there are many ways of doing it. I'll go with the simple way. I'll create a object of sample C. Okay, so what is happening here? This is your sample A class, which has a main method. This is the first thing that will get called by JVM. You already know this, which will then basically create an object here. It will call the bees do nothing. Bees do nothing will create a sample C class, and it will call the C's this do something method. And then in here, it will basically, it will execute this part. Okay. So what happens behind the scene? Let's see what happens behind the scene. Okay. Let's get rid of this. When your A class has a main method, when you start executing a main method inside A class, right? It creates something called an execution stack or call stack. Okay. It is basically, I mean, if you are familiar with the stack data structure, then it will be helpful to understand what I'm trying to say. But basically, all of these nested calls, they get stacked one on top of each other. As in, you have this execution task, there would be one call stack here. Then if you call something else, there will be another call stack here. If another method is called after that, then there will be another call stack here. Okay. So when you start your program, okay, you can imagine this big box as your JVM. Okay. Let me make this big for you. Okay. This is your JVM. This entire big box is your JVM. Okay. The first call that was done here was to the main call. Okay. This is what happens behind the scene. Okay. So when you're like, for you to understand, let's call it A, and let's get rid of this. Okay. Cool. So for example, let's just say that these two things are not there. Okay. When your JVM enters, and the first thing it encounters is this main method. So it creates in the call stack, it creates this chunk here, okay, called main. It basically occupies the memory and do this thing. Then it figures out that main A actually calls do nothing of B. So what happens is it creates one more, it basically occupies one more segment of the memory, which basically calls do nothing on B. Okay. This is still happening inside your JVM's memory. Okay. Then when do nothing, it goes to do nothing and it says, okay, there is a call to do something. So what it does, it creates another call stack here called do something of C. Okay. This has, so far, this has nothing to do with exception, but it will help you, like if you know what call stack is, it will help you understand exception handling better. Okay. So remember this thing, like if you have one call after another, right? It keeps on piling up like this. So when your do something is done, JVM will remove it from here. Then it will come to, let's say do nothing's B, and then at do nothing's B, you have one more call here. Okay. Some other call, some other method call you have here. So what it will do is it will create one more call stack right here. Okay. But anyways, once your do nothing method is over, as in when it reaches the last line of do nothing, this two will be removed from the stack. Okay. Then it will come to your main method here. And if do nothing was the last line of this thing, by the time your JVM thread leaves this curly brace, the last bracket here, this two will be removed from the stack and your memory will be free. Okay. So this is basically how program execution happens in the memory. You first encounter the main call, then all the respective calls get piled up. 1, 2, and then you can have multiple calls. As each of the calls finishes, they get removed out of this thing. This structure is actually known as stack in data structure. If you have studied DSA, you know that this is a stack. Okay. So what exactly is, where does exception come in? Okay. Let's say you have come to this point before you call this method here, there is an exception at this point. What it will happen here is it will not occupy the memory for this. It will not even create this thing. The moment it encounters an exception here, yeah, anyone has any question? Your voice is too low. Can you hear me now? Okay. How about now? Is it better?
Yeah, yes, sir, I can hear you. But there is some. I think there is some disturbance from the back, like air sound
Disturbance?
is there.
Acha, okay, okay. Okay, okay,
Yeah.
okay. Is it gone? The disturbance?
Yes, sir. Yes, sir. You're much better now. I can hear you.
Okay. Okay, cool.
Thank you, sir.
Fine. Yeah. Right. So basically, as I was saying, let's say there is something that goes wrong here. You throw an exception at this point, it won't occupy this memory. Okay. What it'll do is it'll first check, the JVM will check, is there anyone here handling the method? Not handling the method. Is there anyone handling the exception? If there is no exception handling, for now, let's just assume that there is no exception handling. So what it'll do is it'll immediately remove this guy out of the call stack. It'll come to main and it'll say, do you have a handler for this exception? Do you know how to handle this exception? Main will say, no, I don't. So it'll also remove main from here and it'll free up the memory. Okay. This is basically what call stack is and how exceptions come into picture. Okay. If you have a list of steps happening and somewhere in there you put an exception, it'll not create the next steps unless you handle them. And if nothing is handled, it'll basically fall back all the way to the last method. Okay. Okay, we'll revisit this thing when we're explaining exception handling, but for now, let's just try and understand the different types of exceptions we have here. Okay. So first thing is there are two types of exceptions. Okay. Now, where does exception come from? If I could draw a tree here, that would be helpful for you to understand. Let me remove, or yeah, let me just minimize this for now. And let's just focus on this area. Okay. So we'll try to understand basically the tree or exactly where the exception begins. So in Java, there is something called, you know that everything in Java comes from this parent thing called object, right? Everything in Java that you see comes from object. That's the mother of all the things that you work with. Okay. Right. Then there is something called throwable. All right. This throwable is basically the parent of all kinds of exceptions here. Okay. After this, so let me just draw the arrow for you to understand. Okay. After this, you have basically two types of exceptions here. Okay. Compile time exceptions. They're also known as checked exceptions. I'll tell you why they're called this way. Okay. And similarly, you have something called runtime exceptions or unchecked exceptions. Okay. If you have any problems or if you think that there is anything wrong, you cannot see something, let me know immediately. Okay. Cool. So basically, this is how the tree is when it comes to exception. Okay. And we'll verify that in a moment. So everything comes from object in Java. Then you have throwable. And then you have basically two different types of exceptions, runtime exceptions and exceptions. So in Java, if you come here, right, you will be introduced to something called, so basically anything that has exceptions added to it, it will be an exception. So for example, you can check this class here. If you are on IntelliJ, you would press the shift twice. Okay. Then it would open up this for you and just type their exceptions. Okay. Or just exception. I think for you, you have to, like if you're on IntelliJ and you have done this, there is something called include non-project items. Tick that, and then it will give you this thing. The first thing in the list you see is exceptions. Okay. And if you see here, this is basically, I don't know if you have ever gone through a documentation or not, but this is basically how a typical Java documentation looks like. This is the markup of exception class. And this exception, as you can see, extends from throwable. Okay, so like how I explained here in this image, that throwable is the parent here. This extends from throwable. Okay, and throwable extends from serializable, which again is basically an object. Okay, now, yeah, this is your exception. Then there's something called runtime exception. Okay, if you go to runtime exception, you will see that it actually extends the same exception, and then this which basically extends the throwable. Now you might have a question. Well, in here you said that they both extend from throwable, so how come this guy is actually extending from here? So initially when Java came out, there was no concept of runtime exception. There was only the concept of compile time or checked exception. I'll get into the definition of each of them in some time, but just know that initially when Java came out, there was this exception only. Okay, then as they started to code, they realized that they needed to have a runtime exception. Okay, and that's why they created the runtime exception. But now let's understand exactly what is compile time exception and what is runtime exception. Okay, so a compile time exception, actually, I'll actually open this thing like rather than compile time exception. Okay. Okay. Yeah. So basically, compile time exceptions are also known as checked exceptions. And exactly what is a compile time exception? So the idea behind compile time exception is it is something uh, which will tell the compiler, tell the Java compiler that, hey, there's a possibility that things can go wrong here. Okay. Let me repeat that again. Compile time exceptions are basically an indication to the Java's compiler. If you write any method with compile time exception, the compiler will warn you that there is a possibility that it can go wrong at this point. So basically, that's what a compile time or checked exceptions are. These exceptions are actually handled at the compile time itself. Okay. Runtime exceptions are basically the opposite, as in they are sneaky exceptions. They are unchecked exceptions. Okay. They are exceptions that the compiler cannot detect immediately. Those exceptions happen at the runtime. Okay, there are reasons why the Java guys first introduced exception and then later felt the need to introduce something like runtime exception. We'll get into that discussion later, but for now just know that checked exception or compile time exceptions are exceptions which the compiler can detect immediately. Okay, runtime exceptions are exceptions that the compiler will not be able to detect at the time of compiling. What do I mean by that? Okay, uh, let me go ahead and let me actually write this method. Okay, so for example, let's say sample C, right? This is our method. Okay, this method will throw a compile time exception. Okay, and whoever is using this method, okay, whoever is calling this method, the compiler will force that class or force that method to handle this exception. Okay, what do I mean by that? So, okay, let's okay, should I introduce you to throw or throws right now? Let me just check, because okay, one second, huh? Give me 1 second. I'm just going to check one thing. Is there a compile time exception here somewhere? Okay, cool. All right. So let's say this is our sample C class, right? I'm going to work with something called URL. Okay, Java has something called URL class, and the purpose of working with that is to show you what compile time exceptions are. So let me go ahead and write a string here: private static final string URL. Let's say www.google.com. All right, something like this. Here, what I'm going to do is I'll say URL. I'll use this class from java.net. Okay, URL new URL. All right, pass this URL here. Okay. Okay. Do you see this thing here? This basically gives you a warning saying unhandled exception, Java net malformed exception. Add exception to method signature. What is this? This is the compiler, Java compiler, telling you that there is a possibility that this things can go wrong at this point. You need to handle it. Okay. This is basically what compile time exception is. If you click on this class, okay, you can see that it basically throws malformed exception. Don't worry about this keyword right now. I'll explain in detail what this does. But for now, let's just know that when you call this URL class here, it gives you, there is a possibility of having a malformed URL exception. If you dig deeper into this thing, you will see that it extends IO exception. If you go into this thing, you will see that it actually extends exception. As I told you, exceptions, the classes which are directly children of the exception classes, they're always compile time exceptions. As in, if you have this thing anywhere in your code, your compiler will give you a signal like this. It will tell you that, hey, you need to handle this thing. Otherwise, there will be problems. Okay. We'll come to the handling part later on. Okay. But let's see how runtime exception is basically handled. Okay. So let me take a look at runtime exception class here. Okay. So there's this famous exception called arithmetic exception, or even more famous is, any questions, anyone? Okay. All right. I don't know why it's not showing. Anyways. Okay. So we'll see what, so you saw this example that the moment I tried to call the URL class, the compiler told me that there's some exception that you have to handle. That was your compile time exception. Okay. What are runtime exceptions? Let's see. Okay, so I would basically, if you are in your system, you would say system.out.println. Okay. What I want to do here is I want to basically print something. And here I want to perform a mathematical operation. Okay. For that, I'll say int r equals 0 divided by 0. All right. This is what I want to do. You can see that IntelliJ gives you this thing saying numeric exception, overflow expression and everything, but it doesn't give you any, the compiler doesn't warn you about this thing at all. Okay. So what I'll do here is I'll actually put an R over here. Is that, acha, okay. Sorry. Result. Okay. What I'm doing here, I'm trying to divide 0 by 0 and then doing this. And this class, this entire method is actually being called by sample B. I'll close all of these classes here. Okay. Sample B is basically calling this method on sample C, and sample A is calling B. Okay. Let's run this thing and see what happens. If you run this thing, you will get this exception. What is this exception? It comes from arithmetic exception. Okay. It says that divided by 0. Ideally, you cannot divide anything by 0. That's a mathematical error. Okay. But you can go in here and you can see that the compiler did not complain whatsoever. In fact, if I show you what happens in compile time error, let's say I say URL, right? U new URL, and then I pass this URL, right? Okay. If I try to run this method, okay, so here I'm just demonstrating the compile time exception. So if I try to run this method, you will see that it won't even run. Like it won't even build. Okay. It won't even build, and it'll basically give you this error here. Unreported exception, malformed exception must be caught or declared to be thrown. Okay. So, and it gives you the exact line number where it's coming from. It's coming from sample C. If you click on this thing, you will see that it's actually coming here. So compile time exception, if you have a compile time exception and you have not handled that exception, your compiler will not let you proceed. Your program will not build, your compiler will not let you proceed this thing. This is the major difference between compile time and runtime exception. In this case, I can see that my program was not even compiled. Even before it was compiled, it stopped the execution at this point, okay? However, if you run this thing, okay, and just to like you can, you know, if you want to see if this really works or not, let's actually put a few logs here. Okay, I'll use system.out. I'll say at a. Okay, let's copy this. I'll add this comment, this print statement at every step so that you know exactly what part it's getting executed and what part it's not getting executed. In the C part here, I'll basically put at C after this execution of this thing. Okay, let's see what it does for. I'll uncomment this. I'll comment this. Okay. So what did I do here? When I run this application, this guy will be printed. Then it will basically print this. And let's just say for the sake of debugging, at a end, something like this. Okay. Simple comments here. And if I try to run this application now, you won't be able to see any of the logs here. No logs are printed because it's a compile time error. You haven't handled it, so compiler won't let you compile this. Okay, get rid of this, comment this out, and try this. Okay, and run this again. Okay, now when you run this thing, you can see that at a is printed. Where is at a coming from? This thing, which means this line got executed. The fact that this very line got executed means the compiler was not able to detect the error. The compiler did not know that there was a possibility of an error, so it did not warn you. So you were able to execute it at this point. Then it went to add B, which means it executed at this point. Then it basically called do something on this. Okay, you can see that it is at this point that it failed here. Okay, it failed at this point because neither result nor at C were printed. Okay, so execution, exception, everything stopped at this point itself, which means if you look, if you remember the picture we drew here, right? I think now you'll be able to relate it. Your main A was able to be created. Do something was also created. C was also created. But as soon as it found an error, C was thrown out because nobody was handling it. It then said, hey, is there any, so, okay, let's do it again, okay? You have C here. Okay, 1 second. Oh my God, wait. Okay, so basically what happened in our case is it came to C and it tried to execute it, but at that point it basically saw an error and it asked, do I have anyone to handle me? No. Kick this guy out. Okay, then it comes to this B here. Okay, and it says, do you know how to handle me? It says, no, I don't know. So it gets kicked out of the memory as well. Then it comes to A and it says, do you know how to handle me? A says, no, I don't know. So this gets kicked out as well. So basically with that exception thrown there, you basically stop the execution of the entire flow and you freed up the entire memory. Okay, and if you look here, right, you'll see this thing, like if you check the log here, you'll see that it says exception in thread main Java lang. It tells you what type of exception it came. It came with arithmetic exception. And if you click on this class, you see that it actually extended from runtime exception. Now, remember I told you that any class, any exception that is a direct child of just the exception class, those are compile time exceptions or checked exceptions. Why are they checked? Because they're checked at the compile time itself. Anything that is a direct child of runtime exception, okay, or like like if you have another exception which extends this, which means that the grandparent is this exception, anyone that is a descendant of runtime exception is going to be a sneaky exception or unchecked exception or runtime exception. Okay, any questions on this? Anybody has any confusion or want me to explain again as to what compile time and what runtime exceptions are? Okay, cool. I'll take that as no questions. All right. So you now understand what a compile time exception is or a runtime exception is. Okay. Compile time exceptions, your compiler won't know anything. Okay. Runtime exceptions, I'm sorry, compile time exceptions, your compiler will signal you if you don't handle it, because right now we haven't handled this thing. So it's throwing me this thing. Runtime exceptions are sneaky exceptions, unchecked. So your compiler won't be able to tell where it happens. So it will go all the way into execution, and deep into the execution, it will figure out, oh, there's an exception. It will stop the execution there. Okay. So this is like a partial execution. And in compile time exception, it will be no execution at all. Okay. Cool. So that was your basically checked and unchecked exceptions. Okay. I'll come to user defined exceptions. Okay. So there are exceptions which are predefined, as in it comes packed with the JDK. You saw this thing, for example, if you click on this class, you see that there is a malformed exception, malformed URL exception. It comes from this java.net package. So it comes as part of the JDK. Okay. Similarly, if you go to arithmetic exception, you can see that it comes from java.lang, which means that it is again part of the JDK. Okay. So these exceptions are predefined exceptions. You can also create your own exceptions. Okay. For example, now the question is, why do we need to use, or why do we need to create a user defined exceptions? Okay. If you see here, right, it says that exception in thread main.java lang divide by 0. Okay. For our case, it's very simple. If you look at this thing, you will know that, okay, there was an exception. Somebody tried to divide something by 0, and that's why this exception was thrown. In many cases, actually, in most cases, when you work in the industry, you will very rarely be working with predefined exception. You will most certainly and almost always be working with user defined exceptions. Okay. So again, user defined exceptions can also be of two types. Okay. Runtime exception and compile time exception. Okay. I'll show you both the things. So I'll create a new package here, and I'll call it, let's say, exceptions. All right. Then I'll create one more package here. I'll call it, I'll just call them checked. Okay. So you know the checked is the compile time. I'll create one more package here. I'll create unchecked. Okay. Right. So how do we create a checked exception? Let's take this example. Okay. Okay. What are the things here? First thing is, name should not be blank. Okay. Age should be greater than, greater than 18 and less than 60. Okay. Email should not be blank. These are certain constraints for which there is no exception. At this point, my predefined exceptions don't have anything here. I don't have any exception which clearly defines what exactly went wrong here. Because if I'm validating this thing and it fails here, what am I supposed to throw? Runtime exception. But runtime exception, what will it be? How will I know what exactly went wrong? Because all three of them can throw runtime exception. All three of them can throw just the exceptions, right? How do I know which exception is what? Okay. So for that came the concept of user defined exceptions. Okay. So I'll start with the checked exceptions. For that, you need to create a simple exception class here. And this is the basically the convention of writing exception classes. You would say, let's say, invalid name exception. So always make sure that whenever you write an exception, it ends with the keyword exception. Okay. And the part before that describes what went wrong. If you say invalid exception and somewhere in the system it throws an invalid name exception, you know that it was the name that went wrong. If I just throw some exception like this, you won't be able to tell what went wrong. Okay. Oops, sorry. So yeah, invalid name exception. When you do that, you say exceptions. Okay. And that's it. It's just a simple class that extends your exception. And basically, if you want to pass your custom message to that exception, you can create a constructor of this. Okay. Invalid name exception. Right. And you can just call the super method on it. In the super method, you can see that it takes no parameter, then a string message and throwable and all these things. We are going to use the second one, which is string message. Here, I'm going to pass the message here. Okay, that's it. So whenever you throw your invalid name exception, this is your user defined exception. You will, if whatever message you pass here will actually be going inside of this. Okay, and this super will call the exception, and then basically it will print this exception tree here. Okay, it is 8:51 now. We'll take a 10 minutes break. If you guys have any questions regarding anything, let me know. Okay, Google Watch. Sorry, counter. There's a countdown. I mean, it's already, let's just give you a break of 8 minutes. I am willing to take questions now if you have any. If you don't have any questions, we'll come back in 7 minutes. Okay. Uh, so we'll resume the class again. Okay. So this is we actually learned the different types of exceptions here. We learned what checked exceptions are and what unchecked exceptions are. We're now learning user-defined exceptions. Okay. So what are user-defined exceptions? They're nothing but plain Java classes, but they extend either exception or runtime exception class or any of the child classes of these exceptions. For example, I can have IO exception. I can have this particular class extend IO exception, which is a predefined exception. Okay. And this in turn extends basically exception. So if you track the hierarchy, it should all the way, like the last element should either be an exception or it should be a runtime exception. Okay. So in our case, if we do something like this, this becomes your user defined checked exception. Okay. And similarly, if you create something else, like let's say invalid age exception. Okay. And then you basically extends the runtime exception part. Okay. And then you create a constructor here, invalid age exception, pass the string message, right? Call the superclass on it, and just pass the message here. This becomes your user defined unchecked exception. Okay. So just to make things clear, there are two things. Okay. One is user defined compile time exception. Okay. And there is user defined runtime exception. Okay. These are the two different types of exceptions you can have user defined. Okay. Cool. Now, so you have your user defined exception here, but how do you use it? How do you throw and like, how do you tell a method or how do you tell your Java class where to use it? Okay. So there are two keywords here. One is throw, one is throws. Okay. We'll understand each one. Okay. So let's say, let's come back to our, this particular class here. Okay. Let's say this method does, whatever it needs to do. Okay. But then somewhere I want to throw an exception. Okay. For example, I have a condition if true. Okay. Some random condition I'm putting here. I know that this condition will always execute, this just for example, but let's say there is some condition for which you decide that, okay, I need to throw an exception. Okay. So to throw an exception, you use the keyword throw. Okay. And then you basically say throw new. Okay. The exception name here. What type of exception I want to throw here? Let's say I want to throw just a simple exception. Okay. And I'll put my message here, sample exception. Okay, I'll throw sample exception here. What will happen is you can see that this is a checked exception, right? So compiler is telling you, is giving you a warning here. And if you try to compile this thing here, we try to run this thing, it won't even compile. Okay, it will throw you an exception. I mean, it will stop the execution here and tell you that there is something you need to handle at this point. Okay, when I come to this point, you see that it throws an exception. And if you hover on this on IntelliJ, it says unhandled exception. This message you get only in checked exception. Okay, because this is a message that compiler is throwing you. So there are two ways to handle any kind of exception. Okay, I'll show you one of the ways. Okay, so if a method, anywhere in a method, there is an exception thrown. Okay, for example, in this condition, if this condition is true, then there will be an exception thrown, right? In that case, you have to, one of the ways to handle the exception is add a signature to the method, which basically says that this exception can throw, this method can throw an exception. Let me repeat that again. If anywhere in your code there is an exception being thrown with this throw new keyword, how do you throw an exception? you say throw, you create a new object of the exception, okay, and then you pass the message to it, okay. If your code has anything like this, then there are two ways to handle it. One is using a try catch block, which we will see later. The other one is saying that I don't have a way to handle it. Please give it to someone else. Okay. For that, you basically add something to the signature of this method. You say throws. Okay. And then you pass this exception class here. What does this do? You can see that the compiler immediately takes the error out of this thing. As of now, if you look at this class is perfectly fine. There is no error. It says a related problem, but nowhere in here you see a red underline here, okay, which means this class is fine. So what did we do here? We said that this method basically says that for this particular exception, I don't know how to handle it, or I don't want to handle it. I want whoever is calling me, I want that method to handle it. That you signal by using this keyword throws exception. If you have any doubt about this, and if you want me to repeat it, I'll repeat it again. Let me know if this part is confusing for you.
Yes, sir. Repeat again this part, sir.
Right. Okay. So you understood the way we can throw an exception, right? Let me actually recap. You understood why exceptions are required, right?
Yes.
Hello? Yeah.
Yes.
And you understood how to throw exceptions? Cool. Now, when you throw an exception, you need to handle it, right? So there are two ways to do this thing. Either you handle it yourself, which I will show you in some time, or you do not handle it and you give it to someone else, okay? This is the part by which you give it to someone else. If you remove this thing, okay, compiler will immediately tell you that, hey, you need to handle this thing. Okay, you can see the red underline coming again, and it says that you have to handle this thing. Okay, for now you say that I don't want to handle this thing. Whoever is calling me, let him handle it. So you would add this keyword, throws exception. Okay, when you do this thing, compiler will say, okay, you are clear. I will see who is handling you and I will force that person to handle it. Okay, so if you come here, if you click on this method, you can see that it actually comes to B. Sample B, do nothing. Do nothing is the method which is now being given the warning by compiler. Compiler is now telling you, hey, you have called a method. This guy throws an exception. You either handle it or you do something else. Okay. B says, okay, I'm going to handle it. So B is going to basically wrap this inside a try, and it's going to catch this exception. Okay. This is B handling the exception within itself. It is also called eating the exception. You eat the exception at this point. You don't allow the exception to go up. Okay. Which means if you look at our stack here, if we come back at our stack here, this was your main method. This was your do nothing method. This was your C method. As soon as your exception occurs, C goes out the window, but B says, I'm going to handle it. So B doesn't get popped out. B handles the error. So B stays within the memory. Okay. This is what happens when you wrap this particular piece of code with try catch. We're going to learn about try catch a little later. This is one way of handling it. If B also says that I don't want to handle it, so what B will do is B will simply just get rid of this. Okay. And B will also add this thing to the signature, throws exception. So what will happen is C says, I produce an exception, but I don't want to handle it. B says there is an exception, but I don't want to handle it. So give it to the guy who calls me. If you now click on this method, you see that the responsibility to handle this method, the error, actually comes to sample A. This process, this whole process of transferring the exception handling from C to B to A is called bubbling up exception. We bubbled up. We bubbled from here to here to here. If you think of it as a top-down approach, A was the one who got called first. If you look at it in this way, you can think in like for the human mind, it is A that got created first, then B that got created first, then C that got created later. Okay. What then happened was C produced an exception, but it did not want to handle it. So it bubbled it up to B. B recognized the exception, but did not want to handle it. B would then bubble it up to A. Okay. Now, when it comes to A, there is no one else here. JVM won't handle it for you, right? So JVM will force A to handle it. So at this point, basically, there are two things that A can do. I'm sorry, my bad. My bad. Okay. So at A, either A handles it or A basically delegates the task of handling it to JVM. Okay. What A will do is A can either wrap this inside a try catch block. Sorry. A can either wrap this inside a try catch block, right? That means A is eating up this error, or A is handling this error or exception, or A2 can say that, hey, I don't want to handle this thing. So how about you handle it? Okay. So it throws an exception at this point. What will happen in this case is this main method will throw an exception, which will then be handled by JVM. Okay. Let's see an example here. You have an exception thrown here. C is bubbling that exception up to B by adding this throws exception. Okay. B is recognizing it, but B does not want to handle it. So B throws it back, like B bubbles it up. Whoever is calling B is also getting this thing, but A doesn't want to handle it. So it's bubbling it up. Who is at the end of it? It is the JVM. So JVM will handle it. Now, if we run this thing, you can see that there's something interesting you can see here. Okay. This exception that we did here, right? This is a this is a compile time exception. So ideally, it should not even have been executed. Like we should not even have seen these two lines. But because it is being handled by your JVM, JVM will convert it to a runtime exception. JVM will execute all the way to the line before the exception, which means JVM will come all the way here and then it'll throw that exception. You can see that it's add B, add C, and all these things, right? If I change it, because the reason why this got printed is because this exception is actually being handled at the JVM level. If we don't add this, okay, if we don't add this, you won't be able to execute this thing at all. Okay, it'll tell you that there's an exception coming from deep within the class. And if you click on this, you can see that it's coming from this do nothing. Okay, so this is how we handle mostly checked exception. Okay, we haven't seen the runtime exception yet. This is mostly for compile time exception. Okay, when you have a compile time exception like this, you will be forced to either handle it there, okay, or bubble it up. And if you can handle it here or you can bubble it up, you can handle it here or you can bubble it up. Okay, but if you don't do any of these things, nothing will get printed. Like you won't be able to compile. Okay, so this is the bubbling up part. How do we catch it? Let's say I want to handle the error, so I will wrap this inside a try here. Okay, so whatever piece of code can throw an exception, you will wrap it inside a try, and then you will catch that exception here. In my case, I can see if I go all the way down here, I can see that it actually throws an exception, right? So I will say exception E, okay? And I'll just simply print out this, okay? Error, or just print the error. That's it. Okay, if we run this now, let's see what happens. Okay, what happens here? At A gets executed, which is fine. At B gets executed, which is also fine. When it comes to C, it throws an exception at this point. Okay, so at this point it goes out of this thing. Let's just say that we want to print this, okay, just to see if it's executing this part or not. Let's run this again. Okay, so let's look at this. This got printed, then you called this, so this got printed, then you called this. Okay, it threw an exception here. As soon as it threw an exception, it did not even come to this point because B is not the one who's handling it. So B is saying that I don't know the mechanism to handle this thing. So from this point onwards, immediately return it. So this line did not get executed. You can see that at B end is not executed. So it returns from this one. Returns to whom? To the caller of this. Who's the caller? Caller is sample A. Caller here basically says, okay, I have a method to basically catch this error. So it catches this error and it basically prints the error. You can see this thing, sample exception, Java lang exception, sample exception, and then it prints this thing. So if you look at this diagram here, okay, main was created first, then B was created, okay, C was created. So C threw an exception, so it was taken out of memory, okay. B recognized the error, but it did not want to handle, so B was also kicked out of this thing. A stayed because A had a mechanism to basically handle the error, and it also printed this particular part here, okay. Any questions so far, any confusion so far what we did? Anybody wants me to explain? Okay, I'll take that as a no. So yeah, that's basically what the two ways you can handle exceptions. One of them is you handle it at that point itself. The other one is you basically bubble it up to whoever is calling your exception, whoever is calling your method, okay. These things, throw and try catch and all of these things, right? This throw method, you have to basically, yeah, any question, anyone? Abhishek is talking.
Yes, sir.
Yeah,
Sir,
what's your question?
which method are used mostly? सर ये mostly कौन सा use होता है? Throws या try catch?
अच्छा, मोस्टली देखो बेसिकली डिपेंड करता है क्या सिचुएशन, मतलब कौन सा कॉन्टेक्स्ट पे हम लोग यूज कर रहे हैं। तो बेसिकली मान लो कि मान लो तुम कुछ वैलिडेशन कर रहे हो, ठीक है। तुमको 3 टाइप का वैलिडेशन करना है। नाम, मैं मेरा एग्जांपल दे रहा हूँ, नाम, एज एंड दिस, ठीक है। एंड मान लो ऐसा है कि एक वैलिडेशन दूसरे वैलिडेशन को कॉल कर रहा है, मतलब इट्स अ नेस्टेड कॉल, ठीक है, पैरेलल कॉल नहीं है। एक वैलिडेशन दूसरे वैलिडेशन को कॉल रहे हैं, फिर वो दूसरे वैलिडेशन तीसरे वैलिडेशन को कॉल कर रहे हैं, ये एक डीपली नेस्टेड वैलिडेशन हो रहा है। अब तुम्हारा लॉजिक क्या है? तुम्हारा लॉजिक ये है कि मेरे को एक सिंगल पॉइंट पे सारे एक्सेप्शन कैच करना है। उस पॉइंट पे तुम क्या करोगे? उस पॉइंट पे तुम बेसिकली सारे एक्सेप्शन को बबल अप करोगे, मतलब तुम कहीं पे भी वो वैलिडेशन किसी भी मेथड में तुम ट्राई कैच नहीं लगाओगे, ठीक है। मतलब मैं क्या बोल रहा हूँ, अगर हम लोग ये डायग्राम देखें तो मान लो ऐसा ऐसा एक, इसको ऐसे मानो, ठीक है। मान लो ये सी इसके इनसाइड में है, ठीक है, मतलब बी अंदर ही अंदर सी को कॉल कर, मतलब हाउ डू आई एक्सप्लेन दिस थिंग, मान लो ऐसा है, ठीक है, ये इसको कॉल किया एंड इसके थ्रू से एक एक्सेप्शन आया, तो मेरे को सारे एक्सेप्शंस ए में हैंडल करना है, ठीक है। तो मैं सी से थ्रो करूंगा जो कि तुम्हारा बी पे आएगा, बी से थ्रो करूंगा जो तुम्हारा ए पे आएगा, ठीक है। अगर ऐसा सीन था कहीं पे कि मान लो सी ने कोई एक एक्सेप्शन दिया जो बी ने हैंडल किया, बट बी को वहां से और एक एक्सेप्शन, मतलब एक डिफरेंट एक्सेप्शन थ्रो करना है ए को, तब बी क्या करेगा? बी वहां पे इसको कैच करेगा एंड ए को थ्रो करेगा। लेट मी गिव यू एन एग्जांपल, मैं क्या बोल रहा हूँ, ठीक है। सैंपल सी एक कस्टम हमारा जो यूजर डिफाइंड एक्सेप्शन है उसी को थ्रो करते हैं यहाँ से। तो सी एक्चुअली ये थ्रो करता है इनवैलिड, मान लो इनवैलिड नेम एक्सेप्शन, ठीक है। ये इनवैलिड नेम एक्सेप्शन तुम्हारा एक्सेप्शन क्लास ये करता है, तो यहाँ पे क्या करना पड़ेगा मेरे को, ठीक है। इनवैलिड नेम एक्सेप्शन, तो सी बेसिकली एक एक्सेप्शन थ्रो कर रहा है, ठीक है। एंड सी बोल रहा है कि मेरे को ये हैंडल करना नहीं है, आप बी को भेजो, ठीक है। बी के पास ये आ रहा है एंड बी बोल रहे कि मैं वो चीज हैंडल करूंगा, एक मिनट, बी बोल रहे कि मैं वो चीज हैंडल करूंगा, बट मैं ए को वो इनवैलिड नेम एक्सेप्शन नहीं दूंगा, मैं उसको कुछ और दूंगा, ठीक है। तो बी क्या करेगा इस पॉइंट पे? बी बेसिकली इस ये जो सी समथिंग कॉल है ना, बी अपने आप से ये एक्सेप्शन वाला पार्ट हटा देगा, ठीक है। बी क्या करेगा? मान लो बी यहाँ पे इसको ट्राई कैच में रैप करेगा, ठीक है। इसमें क्या कैच करेंगे हम लोग, इनवैलिड नेम एक्सेप्शन, ठीक है, जो कि तुम्हारा एक्सेप्शन चेक से आता है, ठीक है। हुआ। अब ये क्या करेगा, यहां से ये बेसिकली एक मान लो कुछ और एक्सेप्शन थ्रो करेगा। मान लो ये यहां से थ्रो न्यू मान लो इलीगल आर्ग्यूमेंट एक्सेप्शन थ्रो करेगा। इलीगल आर्ग्यूमेंट एक्सेप्शन तुम्हारा, सॉरी ये रन टाइम एक्सेप्शन है। मान लो दूसरा कोई एक्सेप्शन थ्रो करेगा, मान लो आईओ एक्सेप्शन थ्रो करेगा, ठीक है। आईओ एक्सेप्शन क्या है, आईओ एक्सेप्शन तुम्हारा एक्सेप्शन है, ठीक है, तो मतलब कंपाइल टाइम एक्सेप्शन है, ठीक है। मान लो इसने बस ये किया तो ठीक है, तो इसमें इसको क्या करना पड़ेगा, इसमें ये लिखेगा थ्रोज आईओ एक्सेप्शन, ठीक है। हुआ। अब ए पे जब आएगा, ए पे इसको आईओ एक्सेप्शन हैंडल करना पड़ेगा। तो तुमने जो पूछा कि कौन सा ज्यादा यूज होता है, ट्राई कैच या थ्रोज, आंसर है कि तुमको वो डिपेंड करता है यूज केस के ऊपर, ठीक है। अगर ऐसा है कि एक मान लो एक सिंगल प्लेस है जहां पे तुम सारे एक्सेप्शन हैंडल कर रहे हो, तो फिर वहां पे तुम बस एक्सेप्शन थ्रो करते रहोगे, ऐसा कोई ट्राई कैच कुछ नहीं होगा। मतलब जो तुम्हारा पेरेंट क्लास है जहां पे तुम सारे एक्सेप्शन हैंडल करोगे, वही बस सारे एक्सेप्शन हैंडल करेगा, बाकी जितने भी मेथड कॉल हो रहे हैं सब बस थ्रो करेगा, उसमें कोई ट्राई कैच नहीं रहेगा। बट अगर तुम्हारा एक ऐसा सिचुएशन आया, ऐसा एक कंडीशन आया जहां पे तुमको एक एक्सेप्शन लेके उसको दूसरे एक्सेप्शन में कन्वर्ट करके फिर भेजना पड़ेगा, उस जगह पे तुम इसको ट्राई कैच में रैप करोगे एंड वही एक्सेप्शन को तुम दूसरा कोई एक्सेप्शन के अंदर डाल के वापस भेजोगे, ठीक है। डज दैट आंसर योर क्वेश्चन अभिषेक?
यस सर।
ओके। अब देखते हैं कि ये सब झंझट में कैसे ना पढ़ना पड़ता है, ठीक है। फॉर दैट वी यूज समथिंग, हाँ, फॉर दैट वी यूज समथिंग कॉल्ड इन रन टाइम एक्सेप्शन। रन टाइम एक्सेप्शन का मजा क्या है कि रन टाइम एक्सेप्शन अगर तुम थ्रो कर रहे हो तो ये सब का जरूरत ही नहीं है, ठीक है। यू कैन सिंपली थ्रो दिस इनवैलिड, कहाँ गया, इनवैलिड एज एक्सेप्शन, ठीक है। अगर तुम ये, if you're just throwing this invalid age exception, which is a runtime exception, you can see that compiler would not force you to handle it because compiler doesn't know that this can throw an exception, which means that your method here becomes simpler. You don't need to do this, okay? You actually don't need to do any of these. To your compiler, this would look like just simple bunch of Java lines code. Your compiler doesn't know that there's a possibility that this can throw an exception, okay? And in sample A, it'll also tell you that there is no exception. You can see that it's coming here. It says exception, IO exception is never thrown in the corresponding try block. Okay, that's true. That exception is never thrown. In fact, if you wrap this with any kind of exception, I think any kind of exception will be caught. Yeah. Okay. So compiler, if you get rid of this thing, compiler will not force you to handle anything. Like compiler doesn't even know that this exception exists. When you run this thing, you will then see that there is a problem here, okay? Where is that problem here? It comes from this thing, sample execution. It comes from B. It basically printed at A. It then printed at B, but then it was not able to print anything after that because this line here threw an exception. Okay, one more important thing about exception is that exception stack trace. This is called exception stack trace. If you look here, the first thing in the exception part is showing you what type of exception is thrown. You can see that this is our invalid age exception. Where is it coming from? It is coming from exceptions package. Inside that you have unchecked package inside that. So if you click on this invalid exception class here, okay, and then click on this particular icon, you see this cross here, select open file. If you click on this, basically in here, it will tell you where the file is located, okay? Sample exception is the message that you have given here, which is the message that I gave there in this part, sample exception. And then it shows, the first line shows exactly where it first occurred. It occurred in sample C line number 14. When you click on this thing, it brings you here. So you know that this is the starting point of this. Then I told you about the stack, right? If you imagine this stack, you have 1, 2, and 3. Similarly, the first guy that encounters the error will be the first line to be printed. Then whoever comes after that will be printed. After this, you can see sample B is the one that found the error at line number 10, which means at this point, it found the error, okay? Then at line number 8 of A, if we click on this, you can see at line number 8 here, this guy found this exception. This is basically called the exception stack trace. If you ever run into an exception and you want to drill down, you want to dig down to find out where the exception came from, this is how you would do it. Okay, so you saw the difference between compile time exception and runtime exception. Okay, if you have a method here which throws any exception, okay, if it throws any exception, there are two things you can do. You can either handle it within the same method, okay, as in like if I want to handle this thing within the same method, I'll just simply wrap this inside this, and then nobody would complain about anything. I will wrap it inside a try catch and I should be done. Okay, yeah, that is one way of handling it. If you don't want to handle it, you want to bubble it up, you add this throws. Okay, but what type of like for what type of errors would you use this throw? This throws keyword will be used only for compile time exception. Any Java class which extends exception directly or indirectly, for them, this throws keywords has to be there. If you throw, like if your class throws an exception which is of runtime, okay, which is of runtime exception, you will not need your method to be marked with the throws. Okay, this is the major difference between runtime and compile time. Now, the biggest question is, why are there two different types of exceptions? What is the need for that? Okay, so let me explain to you under what scenarios you would be using what type of exception. Basically, if something is extremely critical, okay, uh, for example, okay, let's look at this. Let's bring in the URL class again. Okay, right. You see here that this is throwing an exception. Compiler time is basically, it's the reason why compiler is giving an error here is because it basically throws this malformed URL exception, and it is an IO exception, which is at the end of the day a compile time exception. Why did these guys, whoever created this URL library, why did they decide to create a user defined exception? This is a user defined exception, just so you know. I mean, it is predefined for us, but the guys at Java Labs who created this library, for them, this was a user defined exception. Okay, malformed exception basically tells you a lot more about what type of exception it was rather than just throwing a generic exception. Okay, so why did they decide to do this thing? Reason is being, when you basically take a string and you create a URL out of it, there are lots of system resources that you are going to consume. Okay, you're going to use threads, you're going to use CPU cores and everything. So it is always like, you don't want a situation where you have acquired CPU resources, you have acquired threads and everything, and then you run into that error. If you do something like that, then basically what happens is those things are like, those resources are already captured, right? It's already held by your system, right? So, and you don't know how to handle it deep within your flow. Like, let's say you have 7 steps, you're on the 4th step, and then you figure out that, okay, the URL given is wrong. Okay, by that time you have already used a bunch of resources, right? So in order for them to avoid this, in critical situations like this, they introduce this exceptions here. Okay, I mean the compile time exceptions, which will force you to handle things here. The reason why they have put here, they have decided to give a compile time exception is because this is a CPU expensive operation. Converting a string to an actual URL is a CPU intensive operation. So here they want to know what you will do and how you will handle it in case something goes wrong. Okay, they want to know that, and they want you to handle it at this point itself. Okay, but in most cases, in our cases, as we start working with Spring Boot application, we will see in majority of the cases, if something is not critical, you are more likely to use your runtime exception, especially if you're creating something called API. If you're designing an API and you're writing a bunch of methods, right? You are more likely to write runtime exceptions. Okay. Yeah. Any questions so far? Anybody wants me to explain anything? Cool. All right. let's see how we can. So here we saw an example of runtime exception, and we saw how the compiler doesn't force you to handle anything. You can actually wrap this thing inside a try catch block. And by the way, this is how we write try catch block. We write try curly braces, okay, then we write catch, and then we basically write what type of exception we want to handle. Okay, now let me show you something interesting. Okay, so here we saw throw versus throws, try catch. Let's talk about multi-catch. Okay, so it's very rare that one method will throw exactly one exception. There is a possibility that C throws one exception, but B also throws one more exception. Okay, that can happen. Let's see. For example, let's say this throws a invalid name exception. Okay, this throws an invalid name exception. What is this? What is acha? Okay, this is throwing an error because there's no exception here. So I'm going to say throws invalid name exception. This is done. Okay, C throws a checked exception. Okay, B here also throws some other type of exception. Let's say B here says that, hey, I don't throw it, but there is a method inside me which throws an exception, so I'm not going to handle it, so I will give it to you. So what it will do is it will say invalid name exception. Okay, done. B is in the clear. But what if B itself has another exception? Let's say B here, if true, okay, B also throws an exception. Throw new. Let's say it throws an IO exception. Okay, IO exception, as we know, is a compile time exception. So at this point, right, there is a possibility of exception coming from C, and there's also a possibility of exception coming from here. Okay, so this method can throw more than one exception. One of the ways to do that is by adding this IO exception. Okay, when you add IO exception here, what will happen to A is A will now have to handle both the exceptions. Okay, A will have to handle invalid name exception, and it will also have to handle IO exception, because so as you go up the ladder, if you have more exceptions added, the main guy who handles all the exception will actually have to like handle multiple exceptions there. Okay, so this here throws one exception, this here method can throw two exceptions. So when it comes here, it will basically catch both the exception. It will say invalid name exception. Okay, you can either write it like this. Okay, you can add one more catch statement here saying invalid IO exception. Okay, this is how you handle multiple catch blocks. Like you can handle multiple exceptions here. Okay, yeah, so this is essentially just a multi-catch. Let's say you have 1,000 lines of code here. Let's imagine you have many codes here that throw many different exceptions. If you want, you can have a catch for each of them. Okay, let's say it throws just a normal exception. Okay, then this is how the order will be. So basically what happens is whichever exception is thrown, if it is coming from sample C, it will be caught here. If it is coming from this, it will be caught here. If it's some other random exception, it will be caught here. Okay, let's try that out. Let's say it is throwing you invalid name exception. Okay, for the time being, I'll write this as false so that this doesn't get executed. Okay, or what I'll do is I'll let's say string s equals something. Okay, and I'll say if s equals null. Okay, if it is null, then throw this exception. In this case, it won't be null, so only C will be throwing an exception. And here I'm going to print all the errors. Okay, so sr, I'll print E here, or I'll just say coming from C. Okay, similarly, I can just come here and say coming from B, and then I can write here general exception. What's happening here? Let's see. What's happening here? You're calling a method here. This method can throw two different types of exceptions so for A has to handle this one and this one. For now, let's just forget the exception because there's no class that's throwing exception directly. Okay, there are two possible exceptions that can be thrown here. A has decided to add two multiple catch blocks. Okay, one for invalid name exception, one for IO exception. When we run this method here, you can see it basically prints at A, which means it prints this line here, which means we know it's there, and then it goes to B do nothing. In B do nothing, it prints add B. We can see that add B here. Okay, we know that this worked fine. It comes here at C do something. Basically, it throws an exception. Okay, so which means that none of these lines will be printed. Okay, which means it will come all the way up here and it will say, does B have a way to handle it? B does not have a way to handle it. So B will bubble it up by using this throws keyword. It will come to sample A. Then you can see here, it says coming from C. Where is coming from C? Coming from C is actually inside this invalid name exception. Okay, so the error, regardless of where it came from, it was caught in the right block. Okay. Another way of doing this is, like, for example, let's just say that I explicitly set this to null. Okay, which means this is the part where the error will be. And let's just say that I'm going to go to C here, and for now I'll just turn this off. Let's say that this exception does not throw anything. Okay, if I run this thing, okay, you will see that it comes to at A. Okay, C, we don't have any log, so C printed out just fine. Then the next log is add A end. Okay, it says add B, which is basically this, and then it throws an exception at this point. Okay, which is then caught by A. Where is it caught? It caught here, coming from B, IO exception, and then it basically prints this particular thing. Okay, this is how you handle multiple exceptions. Okay, now what if you have, let's say, 100 different exceptions? Okay, you can either write 100 different catch blocks like this, or another way of doing it is get rid of this. You have to decide the parent of these two exceptions. Okay, what do I mean by that? Invalid name exception comes from exception. Okay, IO exception comes from exception. Okay, which means that the parent of these two exceptions are exceptions. What happened if instead of throwing IO exception, this guy threw malformed URL exception? Okay, what will happen then? The parent of malformed URL exception is IO exception. The parent of invalid name exception is only exception, which means that's not going to work, right? So you have to, if you want to catch the exceptions commonly, you will basically then have to find the common parent. Okay. What I mean by that is sample B has two exceptions, invalid name and malformed. Invalid name has exception as the mother of it. Malformed has IO exception. IO exception has exception, which means the common parents are exception. So what I'll do here is, instead of writing these lines here, okay, I'll just say exception E, and in here I'll use something else. I'll say if E is an instance of, okay, now that E is here, I don't know which one is what, right? So I can say E is an instance of, if it is an instance of malformed exception, then do something, or else do something else. Okay, if it is not malformed exception, then it must be something else. Okay, you can also just like explicitly mention invalid name exception, then do this. Sorry, if okay, then do this, else do something else. Okay, is this clear what we did here? Instead of having multiple catch blocks, we wrapped everything inside, but what did we wrap with? We wrapped it with the mother of all the exceptions. So we went to the exceptions here. We found out what was the common exception for these two. Exception class was the common exception class for these two things. We caught that, and here we differentiated what is what. Instance of keyword basically tells you whether this here is actually coming from this or from this. Okay, any questions here? I know this might be a little confusing, but ask me if you have any questions. Cool. No questions. That was the second way of handling multiple exceptions. Another way, which is a very simple way of doing it, is basically this IO exception. I mean, whatever we did here, we can just say, sorry, it was not IO exception, it was malformed exception, URL exception, or let's say invalid name exception E. Okay, so instead of like catching just exception here, we caught these two things. Now, what is the difference between this catch and this catch? Let's look that out. Okay, what is the difference between this what is the difference between these two things? Okay, exception class is the parent of all exceptions, right? In your app or in your program, there may be a requirement that you handle only malformed exception and invalid exception, invalid name exception. The requirement is that you only handle these two things. Okay, if you wrap it with just exception, what it will do is it will catch all kinds of exception, which means it will catch even the runtime exceptions, it will catch null pointer exception, it will catch everything, which means if your system requires you to handle only few exceptions and leave the rest, if you wrap it with just the exception here, it will catch all kinds of exception, which means it will eat up all the exception. That's not the right flow, right? To avoid that, what we do is we specify these two things. When you specify these two things, what will happen is if any instance of exception comes and it is either malformed URL exception or invalid name exception, only then it will be caught. If it is not, if the exception coming is none of these two, then it will be thrown out. It will be either bubbled out or it will stop the execution at this point. Is this clear? Or does anyone want me to explain this again? Why the difference between this and this? Abhishek, you have a question? You want me to explain this again? Maybe you can type it out, man. Your internet is too slow. I cannot hear you. Abhishek, can you type it out? Type your question in chat. Clear, sir. Acha, clear. ठीक है. Done. Okay. So that's basically what it is. These are the ways in which you can handle your exception. And what's the last topic? The last topic for today is finally. What is finally? Okay, so we learned what exceptions are and why they're needed, what they do. We learned checked exceptions versus unchecked exceptions, which are also known as compile time versus runtime. We learned how to create user-defined exceptions. It's just plain Java class. You either extend runtime exception or you extend exception. Then we learned the difference between throw versus throws. Throw is when you explicitly throw an exception. Throws you use when you don't want to handle the exception. You want to bubble it up. That's when you add the throws. Try catch is when you want to handle the exception. Multi catch is when you have more than one exception to handle. And let's talk about finally. Okay. So what is finally? Finally basically means that after all your exceptions have occurred and you have handled them, you want to execute something after that. Okay. What I mean by that is if you look at this thing, if you look at this diagram again, the moment your exception is thrown at this point, this is kicked out. This guy is also bubbling up the error. So this guy is thrown out. Okay. At the main guy, at the A guy, the A handles the exception. Okay. If you look at this scenario, okay, let's actually put some logs here. This is the last topic, so just pay attention. hello there. Okay. Let's get rid of all of this. Okay. Okay. Let's see. We have basically two logs here. Okay. I'm going to remove all the logs out here. Whatever the logs we have, I don't want to clutter the logs here. So I'll basically remove all kinds of logs from here. Okay. We'll see what finally does. C also has no logs here. Okay. All right. So this line will be printed when the execution starts. Then at this point, it may or may not throw an exception. We don't know, right? At this point, it'll say something else. Hey there. Okay. So there are two things that can happen here. This got printed. At this point, the exception did not happen. It went ahead and printed this. Or at this point, the exception did happen. So it skipped this part. It came directly to this catch block and it printed this. Okay. Let's see how that happens. You can see here, forget about this. I ran this in debug mode. Let me just run this in normal mode. Okay. So you see hello there, right? And then an exception was thrown here and then it came here, which means at this point, at this particular line, it's a binary decision. It's either a success or a failure, right? So your execution can either continue after this point, okay, if the exception is caught or something. If the exception does not occur, it can either continue at this point, or if the exception happens, it can come out of this and it can continue at this. It can start executing from this point. Okay, so this is a binary situation. It's a yes or no. Yeah, any question? Okay. So it's a yes or no. Okay, so you cannot tell for sure which one is going to execute, right? You don't know whether this part will execute or not. If there is no exception, then this will go smoothly. If there is an exception, then this won't go smoothly. But you may have a requirement where you want to execute something regardless of whether an exception is thrown or not. Okay, let me repeat that statement again. You want to have a case where you want an execution regardless of whether an exception is thrown or not. In that case, you will introduce something called finally. Okay, this finally does not take anything. It's not a catch with a catch method which takes an argument. It is just a finally block which will print something regardless of, I'll say s out. Okay, system.out.println finished. Okay, which basically means that if this execution happens smoothly, it'll print this and then it'll print this. If this execution breaks at this point, it will print this, but it'll also print this. Okay, which means whatever you specify in the finally part, regardless of what happens, whether it breaks or succeeds, this will always get printed. Okay, we'll see an example here. Let me go inside do nothing and let me turn this to false. Okay, or if it's difficult for you to understand, let me just go ahead and write this as false. Okay, what happens here? C comes here, C has false, so C won't throw an exception. We come here, do something, this is also false, so this won't throw exception, which means the exception will happen smoothly. If I run this thing, you can see hello there, hey there, and finished. So I know that execution happened here and then it came to this part. Okay, now if one of them throws an exception, let's say this guy throws an exception here, okay, which means it will break at this point. If we run this thing, you can see hello there. Okay, coming to C is coming here. Don't worry about why it's not coming in between. It's because I'm basically using error log here. If I change this to just out, right, you can see that execution. You can see this hello there. It got printed at this point. Then the flow broke here. So it came here. It printed coming from C, okay, because that's what the log is here. And then it finally finished. I mean, it finally executed this part. So finally block is basically meant for anything which has to happen regardless of whether the execution succeeds or fails. Okay, this completes our topic on exception. Again, exception is like you can learn a lot more about exception, but this much is enough for you to get started on Spring Boot. So we are going to only teach you those things which are required for Spring Boot, and as we start working with Spring Boot, you'll get familiar with this. Okay, yeah, let's see. Let's do a recap. We learned about exceptions. We understood why an exception is required. We understood the concept of call stack. If one method calls another method, then in that stack, there is this that gets piled up. Then if that method calls something else, then that gets piled up. At any point, if an exception happens and that particular call is not handling it, it is thrown out of memory. If this guy handles it, it stays in the memory. If this guy too does not handle this, it will be thrown out of the memory and this guy will handle it. Okay, this is basically how a call stack works. And this is how exceptions affect the call stack. Okay. Then we understood how user-defined exceptions are. We actually created a simple Java class here. Okay. One Java class having invalid name exception. This was our custom exception class name. And it extended just the exception. Then we have something called invalid age exception, which basically extended runtime exception. Okay. And we saw that for runtime exception, you were not forced to use the throws keyword or try catch. Okay. Then we learned about throw versus throws. We saw that if we have to explicitly throw an exception from our method, we did that by using this keyword throw, and then we created a new object of that particular type of exception. Okay, and we passed a message, our custom message, whatever it is. Okay, if you want if you want to handle it here, you would ideally wrap this piece of code or this entire thing inside a try catch. But if you don't want to handle it, you want to bubble it up, bubble the error up, you would add it using, you would add this throws keyword in your method signature. Okay, this is your, this entire thing is your signature. In this, you add the throws keyword, and then you basically type the name of the exception that you're basically throwing. Okay, so in our case, it's malformed. This guy throws the invalid name exception, which we are not handling. So we add it to our throws. And we also, because we are throwing this exception and not handling it, we're also adding it to the method signature. Okay, which means it is now the responsibility of sample A to handle it, which brings us to the topic of try catch. You wrap that piece of code which can throw an exception inside a try block, and then you catch the different kinds of exceptions. We saw the two kinds of exceptions. We had multi catches, okay, where we had catch block, one catch block for one exception. Okay, then we had another scenario where we caught the mother of all the exceptions, which is the exception class here. But we saw that this is a problematic scenario, because if there are some exceptions which are not meant to be caught at this point, they're going to be caught anyways. So in order to avoid that, we narrowed down and we basically said catch only these two exceptions. Okay, which is what we wrote in the code here. We are catching only malformed exception and invalid exceptions, which means if anything else is thrown here, like arithmetic exception or null pointer exception, they will be caught by JVM. Okay. Yeah, that's the try multi-catch. Okay. And if you want to execute something, regardless of whether the execution succeeds or fails, okay, if you want to execute something regardless of that, you would be writing your execution code in the finally block. In my case, I'm just printing a statement, so I wrote this in finally block. Any questions so far regarding this? Is there any topic you feel like you didn't understand? I'll be more than happy to explain. I can take questions now. We have 6 minutes.
Huh?
Yeah. Who's this? Sai.
In user-defined exceptions, we are giving one message as an argument, right?
Yes. So there are actually many things you can. What's your question?
Yeah, there in the method, why aren't we directly printing the message with system.out.println, and why are we specifically mentioning super of message?
So see, if you do not mention the super of this thing, right, you won't get the stack trace.
Okay, okay.
And why do you want to print the message here? Because this is something you're throwing. This is the signal. Somebody has to catch the signal. You won't catch yourself in the same block, right? Understood, right? So this is how you signal the compiler or the JVM, hey, there is something wrong. Now whoever is calling this thing will have to catch it. That's the guy who will print the error. And why do you call this thing? Because if you don't give this thing, the entire stack trace is lost. You cannot tell where the error came from, who was the first line of code that encountered the error. None of that information will be there with you if you don't use this.
Okay, so it will print the stack trace along with the message we are mentioning it for our understanding.
Correct, correct.
Yeah, okay.
Any more questions? Cool. Let me, if you don't have any more questions, I think I gave you there is a homework for this. I'll just take you through that homework and see if you have any issues. Okay, how do I? Okay, I'm just gonna stop sharing the screen for some time. I'll just log in. Give me 1 second. Okay, I'll start sharing the screen again. Okay, so basically, see, this is your curriculum, and there is, I don't know if, do you guys have access to this page, this sheet here? Anybody? Okay, I don't think anyone has access to this. Okay, basically, check with Kabir once. So we'll have these classes, right? And each of these classes will have, not each of them, but some of them will have direct assignment. Like for example, you can see that this class here will have an assignment combined with the assignment 3. So what is this? There is a sheet that I have created here. You can go to the sheet here. And basically there are these assignments here. Assignment 1, assignment 2, assignment 3, okay? Whichever class will have an assignment, I will let you know. And you will basically have to try doing these assignments yourself. If you have any problem, you already know my Teams handle. You can directly ping me there, or you can DM me, whatever it is. But yeah, this is something. So I'll just take you through this. For example, you need to basically create a small Java validation library. You have two validators. You have two Java classes. One is the validator and one is the main. A validator has basically 3 methods: open, validate, close. Just go through these things, like what these methods do. And once you're done, main is the class where you need to test your validator method. Okay, so this is how your assignments are going to look. Each of them have their own link. You can click on them and it will take you there. Okay. If you have any problem with the assignments, or you're not able to understand something, let me know. Okay, any questions? We can end the session if you don't have any questions.
Hello, sir.
Yeah, who's this?
This is Vishwesh.
Yeah, Vishwas, yes.
Sir, I have no questions regarding this particular class, but there are few questions like total, like how long will be this particular Spring Boot session will be going on, sir? Like a month or two?
It'll be more than 2 months actually. But wait, I'm not exactly sure how because I will be taking the concept classes. Okay, it will be definitely close to 2 months for sure. But because we are having more number of classes, like earlier we were just having Sunday and Saturday. This time we'll have 4 concept classes and 2 practice classes. So I think it will be done around like in about 2 or a little more than 2 months. But the important thing is the way this course is designed, right? Majority, like 70% of the Spring Boot application should be done by the time you are reaching the second month.
Okay.
Does that answer your question?
Yes, sir. Yes, sir. Because right now I'm working right now in a particular company, and so the main focus is on Spring Boot only.
Correct. So see,
we are handling the Spring Boot only.
So the reason why we do this is because I understand where you're coming from. Like, these are the things you probably already know. But the thing is that in our class we have people who are just freshers, right? So I have to teach them.
But this class is really helping me a lot, because even I have joined like a fresher only.
Achha.
And and when I'm working, the work environment is a little burden to me, because all these things are very new to me. And so that's why I have continued with the classes again.
Cool. No problem. You can always ping me if you have any other queries about Spring Boot or something. Okay.
Sure. And we are learning all these things, like these are all 3 layers, like service and all these layers thing we are learning, right?
Correct. Yes, we have that course planned out here. Like, if you can see here, we have these you have an entire module dedicated to Spring Core. Then you have your web fundamentals, where we basically describe the client server architecture, and then REST principles, get method, post method, all that stuff. Then you start with Spring Boot fundamentals. Then you come to database fundamentals.
This was my main question. Like, are we handling with some database thing?
Yes. You have this is your complete, like, you have a Spring security here. Then you have a deployment through. I think up to this database access part will cover 80% of your Spring. Like, if you're working on some Spring project in some company, you will most certainly be working with these things.
Yes, sir. Good operations. Yes.
Cool. All right. Any more questions? Okay. If there are no more questions, I will end.
One more thing. Last question. Are we handling with any project kind of thing at the end, or like parallelly we are going the projects, or only at the end we are having some project thing, like anything is there?
Right. So how we'll do this is, you see these little homeworks, right?
Yes.
These homeworks, because I cannot burden the freshers here with like a complete project. What I'll do is, every day we learn something, right? For example, if we learn when we learn the generics, you will have some concepts of exceptions involved in there. Okay. So what will happen is, by the end of this course, like after we are done with the database part, you will have to work on a mega project. Okay, some university management application or library management application, something like that. Okay. This will give you a fair idea of all the 3 layers of a Spring Boot application, database, DTOs, models, and all that stuff. So you will have a mega 1 or 2 mega projects to work on. Okay.
Sure.
Cool.
I completely got it. And so one more thing, when will this class recording will be available? Is this like a next day? Are there any chances to get this recording after the end of the class?
No. So it takes, I think, as far as I know, the processing takes around 4 to 5 hours. So it should be available on the next day itself.
No problem, sir. No problem. That will be fine.
Cool. And you have the group, right? March 22. That in that group, if you have any question, you can ping your questions directly there.
Sure, sir. Sure. I'll do that.
Cool.
Thank
any
you.
More questions, guys? Cool. Thank you for joining, and we'll end the session today. Good night.